In this animation, we will introduce you to the flow cytometry experimental technique. Flow cytometry is used to count and analyze the size, shape, and properties of individual cells within a heterogeneous population of cells. Flow cytometry data is extremely quantitative and can be analyzed in depth by specific flow cytometry software programs. Once a suspension of individual cells has been prepared for flow cytometry analysis from cells, tissues, or organisms, the prepared sample is placed on the flow cytometer. How does a flow cytometer analyze the size, shape, and properties of individual cells? A flow cytometer contains several key components, including the sample, fluidics that move the sample into the flow cytometer, lasers, optics which gather the light, detectors to sense the light, and a computer system to output the data into a form that can be analyzed by the researcher. Once a sample has been placed in the flow cytometer, the machine will suck up the sample, mix the sample into a stream of saline solution in the cytometer, and lead the cell suspension through a narrowing channel, causing the cells to form a single file line before the cells pass through the laser at the interrogation point. Each cell within the sample then moves across the laser beam, allowing each cell within the sample to be individually analyzed. As each cell passes through the laser beam will scatter in multiple directions. The flow cytometer detects light scattered in a forward manner, called forward scatter, and light scattered in a sideways manner, called side scatter. The amount of forward scattered light for each cell is detected by a detector on the far side of the cell from the laser. Forward scatter is proportional to the size of the cell. The detector converts the scattered light into a voltage pulse, which is directly proportional to the amount of forward scattered light. The computer converts these data into a histogram plot with the amount of forward scattered light on the x-axis and the number of cells on the y-axis. The amount of side scattered light is detected by a detector located perpendicular to the path of the laser beam. Side scatter is proportional to the shape and internal complexity of a cell. Just like with forward scattered light, the flow cytometer converts the detected side scattered light into a voltage pulse, which is directly proportional to the amount of side scattered light. By analyzing the forward and side scatter data together, the researcher can understand a cell's size, shape, and complexity. In addition, the analysis of the forward and side scatter data can allow the researcher to divide the heterogeneous population of cells into individual populations with varying size, shape, and complexity. This capability of analyzing multiple populations within a sample is the immense strength of the flow cytometry experimental technique.